Hi everyone, welcome to today's session on Build Intelligent Solutions using Amazon OpenSearch. My name is Muhammad Ali and I'm a Senior Specialist Solutions Architect at Amazon Web Services, where I spend a lot of my time helping customers get value and insights out of their unstructured and semi-structured data assets so they can make effective business decisions in near real time as events happen in their business operations. Today, I will be talking about trending real-time analytics and intelligent search use cases that I have seen my customer build using Amazon OpenSearch service. The talk is divided into two parts. First, I will talk about value of real-time intelligence and how you can help your business detect adverse events such as fraud in a financial system or fault in an application or equipment that you use for your operations. In the second part, I will be talking about intelligent search solutions and how you can increase user engagement by personalizing the search results, which results in improved conversion rate for your business. This is a 300-level talk, and I expect that you have basic knowledge of OpenSearch or Elasticsearch and have very basic understanding of what is machine learning. I will be providing resources at the end of the session, which you can use to learn more about the technologies discussed. Let's start with real-time business intelligence or continuous analytics. By tracking, measuring, and monitoring the business operations, companies are able to influence business outcomes in real time. One of my customers is monitoring vessels in the oceans using Amazon OpenSearch service. This helps them alert the vessels about the heights of the tides, wind speeds ahead, and weather and traffic condition at ports. And the amazing thing was, because they use managed Amazon OpenSearch service, they're able to build, run, and operate the system with just a single individual. So depending on the industry, you're able to answer questions that will help you make decisions quickly. For example, having real-time visibility into inventory levels can help you make replenishments when needed and capitalize on the revenue opportunity or save costs by reducing waste. Knowing of a suspicious authentication activity in real time can help you reduce your reputational risk by taking the preventative measures before a malicious actor harms your business. Identifying fraud in real time not only helps you earn your customers' trust, but also significantly reduces the loss of revenue. For IT and IoT teams, knowing your applications or devices are functioning as expected or sensing a fast-changing business situation can help you react before your business is impacted. All of this is possible by harnessing machine data. Machine data is ubiquitous. It is generated by a wide variety of sources that run or interact with your business operations, such as applications that your users or employees interact with, or integrations with the businesses that you're partnering with. Then we have backend system and infrastructure such as databases, load balancers, and identity systems, etc. All gather data that can be used to draw a picture of your business in real time. With industrial automation, mobile application, and IoT in general, businesses are increasingly sensing and capturing business events in flight as they happen and decide the next best action. The thing about machine data is it's huge and often comes in the form of time-bound events, whether collected in response to users' action or sensed by a system or device on periodic basis. Data is often in semi-structured or unstructured format. This large volume of data cannot be processed efficiently by traditional database store. So therefore, you need a data store that is designed to offer large volume, time series, semi-structured data processing, and that is what OpenSearch offers. OpenSearch is an open source distributed search and analytics suite. Amazon OpenSearch is a fully managed service to deploy, manage, and run open source OpenSearch cost-effectively with industry-leading reliability, scalability, and security. Many of our customers choose Amazon OpenSearch service as it takes away the heavy lifting of operating, maintaining, and securing OpenSearch cluster from their teams and allows them to focus on extracting the value from their data. OpenSearch is a powerful analytics engine that makes these different use cases possible. For machine and log analysis, customers can stream data in high volume in real time and analyze this data using a variety of filters and visualization options. It allows you to collect your application performance metrics, logs, and trace data, and then offers you observability features such as service maps to monitor your microservices interactions and event analytics for you to detect or diagnose root causes when troubleshooting these complex architectures. This capability builds on top of a powerful full-text search engine, which allows you to create complex queries to search your text or metrics data. Now, since at the heart of it, it is a full-text search engine, therefore, it is a very popular choice within our customers to use it to power their e-commerce website searches and any other application that require full-text search capability. So this is how OpenSearch works. You collect the data from your servers or applications or IoT devices, you convert each record into JSON documents, and you send this data to OpenSearch for indexing. Now, OpenSearch makes every field in JSON documents searchable by creating indices for them. Then you use REST APIs or OpenSearch dashboards to run your analysis. OpenSearch dashboard is the user interface for OpenSearch, which users use to create visualization of the data and put together dashboards that gives them single pane of glass view for their operations. Now, your data could be anything from vessel's navigational position or application CPU memory metrics or login events. Or it could be product catalog to be searched from your e-commerce website. Essentially, you can build a variety of use cases with OpenSearch. For the last few months, we are seeing some interesting time series and search use cases that are trending with our customers. A lot of it is about making intelligent systems that use artificial intelligence or machine learning to power your analytics. Our customers are building solutions using OpenSearch to detect frauds, for example, a malicious login request from an unknown IP, or predicting faults in equipment as they happen, so the downtime caused by such failures can be reduced or eliminated. And we are also seeing a large number of customers building centralized logging and health monitoring solutions to observe a large number of applications from a single platform. Within the search domain, we are seeing customers building personalized search and recommendation search systems, and also offering their customers new ways with which they can search their product catalogs. So let's start with fraud or fault detection. Traditionally, this is how it worked. You would collect the data from your equipment, you send it to a times-3 store like OpenSearch, and then you let your user use complex querying capability to create rules based on thresholds, which when breached will trigger alerts. While it works fine if you have a limited number of things to monitor, it definitely does not scale well. It's easy for human beings to detect a pattern in a data set with 1 or 2 metrics or features, but it's really very hard when this is extended to a large number of features. Thankfully, machines are really good at this. With OpenSearch anomaly detection feature, which is powered by a popular random cut forest algorithm, you're able to quickly analyze your log data and identify faults and unusual patterns in real time. This helps you reduce business impact by reducing mean time to detect, mean time to investigate, and mean time to resolve metrics, which are super important for any operations team. And all of that is done without having to have any experience in machine learning or writing any code. Now, if you have thousands of servers and applications, each having different utilization levels and peak usage time, for that, we have recently released high cardinality anomaly detection feature. With this, you're able to detect anomalies from up to 1 million entities. Entities could be your servers, devices, or applications, or different metrics within those servers, such as CPU utilization, or memory, or login events. Each of the entity data stream is looked at individually, and a model per entity is trained on incoming data in real time. Once the model has seen sufficient data, its confidence level goes up, and you're able to identify any spike or unusual data pattern in real time. With that, you're able to track individual error types and get notified as soon as an anomaly is detected in the application. You can configure alerts for your team based on different entities that they own, so they can get notified as soon as a problem is detected in their application. This opens up a lot of opportunities for developers and operators. You could build use cases such as identifying increase in error rates in your application or sudden unusual change in user geography from your security logs, or sudden change in soil moisture level for your greenhouse monitoring solution. Let me take a moment and show you how it looks. So let's log in to OpenSearch to see our application monitoring dashboard. This is OpenSearch dashboard application, which the user used, or the user interface for building analysis and visualizations. What you see on the screen is a dashboard that I have created to monitor 49 applications deployed in 15 different AWS regions across 24 AWS accounts. I capture CPU and memory usage from these 49 applications every 5 seconds. These applications each has its own pattern of usage. Defining rules to capture anomalies in CPU or memory usage will be difficult here. As I zoom in, you can see that there is quite a bit of difference in these metrics amongst these applications. However, I'd still like to know if there is a change in CPU or memory usage that is not consistent with normal behavior. And we can use anomaly detector to achieve this. So let's quickly create a detector. We provide a name description, select the CPU memory usage data index as our data source, and select timestamp field and frequency at which the detector should run. We would then choose the field or metric that we would like the detector to monitor. This would act as the feature to train the ML model based on random cut forest algorithm. We selected average CPU usage as our feature. Since we are building a detector across 49 different applications, we would use high cardinality anomaly detector feature by enabling the category field and pick app to categorize the metrics. We can preview the anomalies and go ahead and finish the creation of the detector. Now, each application CPU usage will be looked at individually by the detector to train a model per application. Detector will be initialized from some sample historical data and will be ready to identify anomalies in some time. Once it's initialized, model looks at the incoming data stream in real time and detects anomalies and shows that in a live anomaly view. When detector picks up an anomaly, it would grade it and also provides confidence level. Confidence of the model increases with time as it has seen sufficient data. You can also run anomaly detection on all your historical data to see if the model is able to detect anomalous pattern from past data. For this demo, I have pre-trained an anomaly detector and already ran an historical analysis on it. Here we see in the history that few of our applications are showing anomalies. And if we dive further, we can see that microservices and logistics application had an anomaly about the same time. Once we click the heat map, we can see the graph of the feature, which tells that there is a spike at the time which is detected by the model. Similarly, if you look at the microservices application, there was a dip in the CPU usage, which is also picked by the model. To show live anomaly detection, I have created a code in SageMaker Notebook to simulate high memory and CPU usage in logistic application. Once I run this code, it will send a few records with high memory and CPU usage, which should be detected by the detector. So let's first confirm that we have spike in the logistic application usage metrics. To do that, we look at our dashboard and search for our application. And there you go. You can see this spike showing up. And we wait for the detector to run at the 10 minutes interval that we set. And as soon as the detector will be run, it will detect the anomaly as it's showing in the anomaly view. Again, if you click the anomaly in the heat map, it shows me that the details, and you can see that a grade 1 anomaly was detected with a confidence level of 0.93, which is fairly high. Now you could also create alerts for your team for each of these applications. So for example, I'd like to send an alert to my logistics team whenever an anomaly is detected in their application. I could configure the alert to send a message to email, Chime, or Slack message. Here, I have configured a Slack integration, and as soon as the anomaly was detected, a team will be sent a message on their Slack channel. And here's the sample message from our anomaly what we just saw. The takeaway from this demo is it is super easy to use anomaly detection feature in OpenSearch to identify changes in behavior in your data and get notified in very short time before your business is impacted. So what we just saw was making our log analytics and device monitoring easier with help of machine learning. Now let's see how we can add intelligence to a content or a product search solution that are also very popular with Amazon OpenSearch customers. Many websites have product catalogs that require natural language-driven search, and search is the most used feature of any e-commerce store. And it could be the first place where you may deliver the right information or product to your user and convert it into a sale, or a place where the user might just abandon your website. We are also seeing a trend in e-commerce that search results are personalized for each user to their preference. Good search user experience is essential to increasing user engagement and driving the conversion rates. Our enterprise customers, on the other hand, are using Amazon OpenSearch service to power their document and enterprise application searches. Now let's talk about how you can improve search experience of your applications by utilizing machine learning and AI innovations. So when we talk about search, what we're talking about is you have a catalog of products, and within there are products that meets your user's requirement. And you, via the search interface, are providing a way for them to locate that product. Users generally use search box to tell you what they intend to buy. To build an intelligent search solution, you have to understand 3 key pillars or areas that help you map the user queries or intent to the products in your catalog. First, you must understand your content or products deeply. This means you know what are the relationship between the products. You should know, the interchangeable vocabulary that users use to look for these products. Second, you must know your users, who they are, what their preferences are, and capture how they interact with your product catalog. Third is the industry domain. You must know how the products and services that you provide are consumed by your users. What are the different concepts and entities that are there and how they are related. This is to understand specific meaning or keywords in specific context. We cover the first 2 topics in a bit of detail now. With machine learning, you're able to know more about your products and their relationships. This is critical to guide your customer through, the checkout journeys. If you know your user has added a pancake mix in their cart, and you know that maple syrup or honey are often bought together with pancakes, you can suggest these items to the user. Exploiting such knowledge cuts down the time user needs to complete the checkout journey and reduces cart abandonment. You can use machine learning to know which products share common language and are similar. And if one is not available, you can recommend the other. This information can be used to also show similar item on the product detail page. In Amazon OpenSearch service, we have added new features for you to create complete new search experiences. You can let your user bring a product image and search for products in your catalog that are visually similar. Pretty much the same way one of my customer, who is an online job or candidate database, lets its users search for potential candidates for a job that are similar to previous successful candidates for similar roles. So how do you do that? The answer is Amazon OpenSearch KNN plugin. Let's walk through an architecture of one such solution. You have a bunch of products, in this case, musical instruments and their images. You run the images of the products one by one through a pre-trained machine learning model that converts these images into a multi-dimensional vector or arrays of floating point numbers. These are also called feature embeddings. You index those vectors with your other product details. Then you let your user bring an image to run a search. Let's say your user brought an image of an acoustic guitar. You pass that image to the model, which converts the image to vector. With this query vector, you call KNN plugin API and find K vectors that are closest to the queried vector. This essentially returns product records that are closest, or in other words, similar looking, and in our case, other acoustic guitars. KNN plugin in OpenSearch supports Euclidean distance search, which works well for image similarity use cases, and cosine cosine similarity search, which works for text and semantic search applications. Now, naturally, the question is, what about this ML model? The good news is a lot of these similarity search use cases can be built with a pre-trained model available in Amazon SageMaker service, which is a fully managed service that provides developers and data scientists ability to build, train, and deploy machine learning models quickly. You can deploy many pre-trained models to Amazon SageMaker with the few lines of boilerplate code. And we will see that in our demo. These models could be used in batch to obtain inferences on entire datasets, for example, before indexing, or could be deployed on SageMaker inference endpoint to obtain inferences in real time, for example, within the search pipeline. Now let me show you KNN in action. This is an application that uses KNN functionality to provide users ability to search female fashion products using images instead of keyword queries. I have indexed over 8,700 dresses in there. The dataset is freely available from Zalando Research. The data is made available through a metadata file in GitHub repository, which provides description and link from where you can download the images. So let's try this out. We will pick a sample image from our computer to run the search. As soon as I pick the image, a KNN query is run behind the scene to fetch similar products. And as you can see, we have very similar looking matches. Let's try it with a different image this time with stripes. And again, you will see KNN will be able to find very similar looking dresses. Let's try one last image, a simple black dress. And there you go, the results for the black dress. So you must be thinking, how did I build this thing? It is a simple 4-step process. I've written a Jupyter notebook that runs through these steps. Step number 1, we download the metadata and images referenced in that metadata to our local disk, and also upload these images to S3 to serve through the UI. Step number 2, we will create a TensorFlow ResNet 50 model, which is pre-trained on ImageNet dataset and made available through SageMaker. This model is used to generate vector embedding that will be used for similarity search in KNN. We will save the model and deploy it in SageMaker with just a few lines of code. Once the model is deployed, we get a predictor object, which can be used to generate a vector from a given image. We will run a sample image through the model to see if the vector embeddings are generating correctly. Now our model is ready. In step number 3, we take all our downloaded images and run them through the model and index the vectors along with S3 URLs in the OpenSearch. Once the data is loaded, we are ready to run similarity search tests. I have 3 random images that I will use as my query. First, a red dress. And you can see similar products are fetched from OpenSearch KNN query. We will use the S3 URL in the response to display the actual images. Let me try again with a different image, a blue one. And you can see similar products were searched instantaneously using KNN query feature. Now I'll leave you with another little demo, a little modification of the previous application. This application uses the same KNN functionality for content similarity search, which means instead of searching on vector embedding of images, we are searching on vector embedding of the text description of the products. We use pre-trained BERT model to turn product descriptions to vectors and use cosine similarity function to run the KNN search. Results for both KNN and default keyword matches are displayed on the screen for comparison. Now for red flowery summer dress query, you will notice that KNN delivers much better results than the traditional keyword search. Similarly, for blue party dress for wedding query, with KNN search returns meaningfully closer results than simple keyword search, which just displays the white wedding gowns. This completes my demo. What we just saw was what you can do with, by knowing your data. Now let's pay our attention to our users. Users are very helpful. They give us a lot of information that they expect us to use to help complete their information retrieval objective faster. You can capitalize on user profile information such as user's location, gender, and other user attributes. On top of that, you can ask preferences, what colors, styles, or genre of products they like, and then you can track or capture what products they interact with when they search with a certain keyword. You can then use this information to provide more personalized search results, which improves the user engagement and eventually results in increased conversion rates. Collaborative filtering is a popular technique to build recommendation engines. You can use this technique to build real-time search-driven recommendation system with Amazon OpenSearch service. This requires you to track interaction of all your users with their product catalog and capture that interaction in a data lake or a data warehouse for offline processing. You aggregate these interaction and calculate metrics such as user ratings, likes, purchases based on different demographics. Then you augment your catalog with this information. Now, when user runs a query, you can add user's personal preference in the query, such as adding weight to certain brand, size, or color, and override default scoring algorithm of the search engine with the interaction information you had. So you just display, or you display the most interacted or relevant products first. As you collect more interactions, your suggestions become more accurate. You can also use machine learning and AI to help you build self-improving search engine, and that is where the Learning to Rank plugin comes in. It is another powerful AI capability available within Amazon OpenSearch service that you can use to learn what your users mean by different query keywords and what products are best representing their intents. With LTR, you bootstrap a model externally to OpenSearch by training it with the training data which contains search queries and what you believe are good product matches. Once your model is trained, you deploy the model in OpenSearch using Learning to Rank plugin. Now, Learning to Rank plugin uses the model in the search processing pipeline. When the search is executed by a user, the search results are run through the model, which will re-rank them based on what it learned from your training data. Re-ranked results are then displayed to the user from your search user interface. Now, here is what makes it really interesting. You can capture how users interacted with these search results and improve the model by training it on captured interactions. This means you can create self-improving feedback loop for your search experience. This is a very effective way to make your search engine smarter over time by learning about your user's intent. Now let's recap what we learned and saw in the session. OpenSearch is a powerful engine that provides or powers real-time business intelligence and search analytics use cases. You can now build AI-infused intelligent solutions with little to no experience in machine learning. High cardinality anomaly detection can help you monitor up to 1 million entities. And KNN and LTR plugins can reduce the time it takes for your users to find the right product, which drives the conversion rates higher for any e-commerce website. Here are some of the resources you can reference for more information about the topics we discussed in today's session. I often find myself surprised by the way AWS customers are creatively using Amazon OpenSearch service to power a wide variety of applications. If you wanted to start your journey of building solutions with AWS, you can start with our rich training resources that are available for free. We encourage you to visit AWS Skill Builder, which is our online learning center that makes it easier for anyone from beginner to experienced professional to build cloud skills or AWS cloud skills. Scan the QR code on the screen to get started now. I hope you enjoyed this talk as much as I did presenting it. We really value your feedback to help us improve our sessions, so please share your rating, and thanks for watching.